So the zeros of a quadratic. We talked about the zeros of a function, yeah? Okay. When you say the zeros of a function, it means where the function actually equals what?
0.
0. Like the output values. The output values equal 0, right?
Yeah.
All right, okay. All right. And when a function equals 0, where are you finding that 0 on the graph?
Where the starting point is.
No, not, I mean, it possibly could be, but generally not. Where on a graph does a function equal 0?
Where the y is.
Okay, well that's 0, comma 0. That's where everything is 0 and y is 0, right? But the function is all the, right? The value of the function is all the y values, the outputs, right? All the output y values. Where do you find the y values equaling 0? Where the graph crosses what? The x-axis. Okay, so the zeros of a function are where the graph will cross the what? X-axis. Just real quick, you look at that graph there. How many zeros does it have? It has 2 of them, right? Now, by the way, when you hear the word zeros of a function, I don't remember if I mentioned this or not, but when you hear the word the zeros of a function, that also means the solutions to the equation, okay? So the word zero and solutions kind of mean the same. I mean, they have a distinction. Like when you say the solutions, it means algebraically. The zeros means graphically, okay? Or the x-intercepts, right? Wouldn't that be the x-intercepts, which is found where y equals what? 0, right? You seeing the connections here? Okay. So here's our equation, our quadratic. Y equals x squared minus 2x minus 3. And it's graphed over there. And so what are the zeros of the function? The zeros would be x equals what? No. X equals 0 is found here, 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 here. Okay. So the zeros, where y equals 0, it's at x equals -1, or where? X equals 3. Notice I separated that with the word or.
It's because it's a parabola.
Not because I used the word or. That's right.
That's what I mean.
Remember, we've had stuff with 2 solutions, right? You don't want to say x equals -1 and x equals 3. Do you remember why not? Yeah, because you can only take on one value at a time. Okay, so you use the word or in between. All right. Now, why would it have 2 solutions? Anybody remember?
Because it's not a square.
When you solve something squared, you take the square root. And how many answers do you actually get when you take the square root of something? 2. What's the square root of 9?
3.
Or -3. Why is it -3?
Because -3 times -3.
Because either if you square 3 or you square -3, you get +9, right? There's always 2 of them when you take a square root. And that's square, right? All right, so part B, they want us to verify that the positive 0 is correct by showing that y equals 0. What do you mean by the positive 0? We have 2 zeros. So the 3. So how are we going to verify that it's actually 0, like algebraically? Huh? Well, no, let's verify it algebraically. Graphically, we can see it, right? So we have this 0 here. There's our -1 and our 3. But how do we verify that it's a 0 algebraically? Well, that's graphically, algebraically. Plug it into the equation, right? So if 3 is actually a 0 to that, which we can see it is here, if I put x of 3 in here, then y needs to come out as what? 0. So let's put that in there then. So we'd have y equals what? 3 squared minus 2 times 3 minus 3. This becomes what? 9 minus 6 minus 3, which is 0. Okay? So 3 is a 0. We could do the same thing with -1, couldn't we? Yeah, well, that should all, we won't do it, right? But if I plugged in -1 here, it would also generate a 0 for y. Okay? All right. Now they want us to factor this expression. Okay, this is one of the simpler factoring ones, right? How to do that? And how do these factors compare to the zeros? Let me just. Actually, I'm going to solve this. I'm going to find the zeros of this algebraically. I'm just going to skip right to that. I think, why bother? So let's write this down. So let's do x squared minus 2x minus 3 equals 0. Okay? And I'd like to solve this, right? You see how I have, by the way, you see how this equals 0 here? What do I actually say is equaling 0 when I write it like that? Y. So I'm algebraically finding the what? Zeros. Which also means what? Solutions. There we go. Which also means the x-intercepts, right? Okay. Let's factor this thing here. Okay. Well, no, okay. I was going to run this by you later, but listen, when you're solving an equation, and I'll write it down officially later, and the equation has an x squared and an x term in it, it has to equal 0 before you can solve it. This one does. If we add 3 to both sides, it doesn't equal 0 anymore, does it? It's something equals 3, right? If you have an x squared and an x term, it's got to equal 0. So let's factor this thing. And as I'm factoring, look at the end, it still equals 0. This is the easy one, right? I need two numbers that multiply to what? No. Negative what? No. 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 I need two numbers that multiply to -3 and also add to -2. What numbers multiply to -3 and add to -2? So -3, -1. Let's make sure. No. Oh, and 1, right? You said 1? Okay. What's -3 times 1? -3. What's -3 plus 1? So that works. Okay. I have a question for you. If I multiply two numbers together, to anything, forget that it's x minus 3, x plus 1. If I multiply two things together and the result of that multiplication is 0, what does that tell you about one thing or the other that you multiplied? One of them or both have to be 0, don't they? Right? Well, how do we handle that algebraically? No. If that, so either this thing equals 0 or what? The x plus 1 equals 0, right? So why don't we just write that down? X minus 3 equals 0 or x plus 1 equals 0. These are pretty easy to solve, aren't they? Now, so over here, what does x equal? You add 3 to both sides, right? So x, do I have to do plus 3 anymore? X equals 3. Or x equals what? That's be -1. Subtract 1 from both sides, right? Wait. X equals -1. Hey, what did I just find algebraically? The same thing I found graphically, right? I found the zeros. But when we do it this way, this is these are the solutions, right? That makes sense? Okay. All right, base of C, Determine where the zeros of, okay, this is a different equation, isn't it? Okay. Determine where, so we got y equals x squared plus 3x minus 10. Okay? Why did they put minus 10? Why did they just suddenly change it? I guess we could do that one. Yeah. Okay. So this has an x squared and an x term in it, right?
Yeah.
An x to the first?
Yeah.
It has to equal what before you can solve it? If it was just an x squared, it doesn't. Okay? So let's take this thing, determine the zeros. That means we set the whole thing equal to 0 and solve it. So x squared plus 3x minus 10 equals 0, right? Do we want to add 10 to both sides? Why not? Right, because we have an x squared and a linear x term, right? So we're going to factor it, right? Get halfway done, x and x. Two numbers that multiply to what?
Negative.
And add 2. So what are they?
-7 and -3.
Go ahead.
-5 and 2.
-5 and 2?
Oh, yeah.
You sure?
And they were, no, 5 and -2.
Okay, what's, yeah, because what's -5 plus 2?
Another.
-3. We want +3, so it's got to be what?
-5.
Plus 5 minus 2. They multiply to -10, right?
Yeah.
And what's 5 minus 2? +3 that we need, right? Okay. If that thing times that thing equals 0, what do I know about?
Just factor it to get the x and y.
There's no y there right now. The y is
Like
0.
the x.
The solutions, yeah.
Yeah.
So what like up we did up here? If these two things multiply to 0,
One of them has to be 0.
or both, right?
Yeah.
So I just do what? X plus 5 equals 0, or, use the word or, what?
Or x -2.
Okay, so what does x equal over here? -5, or add 2 to both sides, right? I hope I don't have to show where I do -5 minus 5, plus 2 plus 2, okay? All right? So that's one way to solve a quadratic equation. If there is an x squared, like a quadratic with also an x term, it has to equal 0. A little bit. Oh, 130 degrees. So this brings us to this little thing here, which is very important algebraically. The zero product property. We just did it. So, right? You know what product means, right? Product means to do what to two things? No, that's sum. What does product mean? Multiply, right? These are being multiplied up here, right? The zero product property. What does that say there? If two or more quantities have a product multiply to 0, then at least one has to be equal to 0. One or the other or both have to equal 0. Okay? So in other words, if A times B equals 0, right? Look up here. This could be like this would be my A and my B equaling 0, right? Everybody agree? So in just the general form, if A times B equals 0, then either what? A equals 0 or B equals 0. Right? And that's the setup, right? So when you have a quadratic like this, you generally end up with two little tiny equations to solve at the end of it. Okay? So let's use that property to solve these. Okay? Are these quadratic equations, guys? Do they have x squareds in them?
Yeah.
They will when you distribute, right? So they are quadratic, right? When we distribute combine like terms, they'll have x squared. So they're just starting us out. We've already kind of done this, right? So like when we get to this point, x plus 7 times x minus 2 equals 0. What do I know? What do I write? X plus 7 equals 0, or x minus 2 equals 0. What does x equal on this side here? No, it does not equal 7.
-7.
-7 or equals 2. It's that's that simple. Okay? Somebody was talking like distributed. Somebody said x squared, right? But if you distribute, like you're really working backwards. Like if we were at this point and then distributed these two, wouldn't we be going backwards? Okay, just saying. Okay, you guys try part B on your own. Should be real quick. What do you do with both of those quantities? Set them both what? Equal to 0. Solve them. Everyone do that now. All right, at least you got that far, right? So over here, if you add 1 to both sides, what do you have? 2x equals 1. And then you do what?
4.
Well, let's finish this one. Divide by 2, you get x equals what? 1. How was 1 divided by 2? 1. Okay, over here. 3x equals what? -4. X equals?
X equals -2.
-4/3. I'm dividing both sides. I'm dividing both sides by 3. I'm dividing both sides by 3.
Oh, I thought it was
Well, this is a different one. That's a 3. Right? So -4/3. Yeah. I don't know. -4/3. And the word or should be in between them. Okay? All right. So let's go to the next page. So to solve a quadratic, if it has an x squared and an x term, it must be set to 0. Okay? If an equation has x squared and x to the first, it must be set to 0. Okay? If it's just an x squared term, you don't have to have an equal to 0 to solve. If it's got also the x for the first term, you do. Okay? So let's use this zero product property here. Let's look at the first one. X squared plus 4x minus 12 equals 0. Is there an x squared term?
Yeah.
Is there a linear x term? Yeah. Okay? So it must equal what to solve it?
0.
Does it equal 0?
Yeah.
It does, so we don't have to do anything. Because like sometimes, you don't have to write this down, I guess. You might have x squared plus 4x equals 12, right? Does that equal 0? So what you would do is what to make it equal 0 if it was like this? Subtract 12 from both sides, right? Okay, but they don't have it like that. So, what is that? All right. So it does equal 0. What are we going to do with this, guys? Factor it. Let's get halfway done. It's a simpler kind, right? X and X. And by the way, the whole way down, I have equals 0, right? Don't drop it. Whatever you guys see me write up here, by the way, you all know, right? Specifically in very fine detail, have the very same thing in your notes, right? Okay, because I don't always see that like on the homework and stuff. Okay. Emily, put a lid on it for now. Somebody else tell me the two numbers that go there and there. 6 and -2, she says. Let's see. What is 6 times -2, everybody? Okay. What is 6 minus 2? So that's going to work. So plus 6 minus 2. What do I do now? Use the zero product property. What do I do? I set both of these factors equal to 0. What word goes in between them, everybody? Or x minus 2 equals 0. What does x equal over here? and 4, x equals 2. Okay? All right. Now, part B. Are we going to have to factor it like we did in A? No. Is there an x squared and an x term? So s equals 0. It already does. We don't have to do anything, right? Okay, so we do need to factor it. We need to get some factors to set them equal to 0, right? So how do we factor this one in B? Well, no, because we don't have this, right? This is even simpler than this. What's the first thing you always look for when you go to factor? GCF, greatest common factor, right? What's the GCF of these two terms? Come on now. Greatest. 2x I can get out of both, right? What's that leave inside? X minus 7 equals 0. Now we just use the zero product property, right? So how do I split this up? What? 2x equals 0 or x minus 7 equals 0. Okay? What's x equal in the first one? Huh? Yeah, divide both sides by 2. How about over here? X equals 7. Okay? So remember, we have more than one way to factor things. But what about in C? Yeah, okay, right. So there's no x term, right? Does this need to equal 0 to solve it? It doesn't, but I'm going to show you two ways on this. You guys know you're going to remember this. Can we factor that? Does anybody notice anything about that or remember anything about a way to, huh? Yeah, I would factor 1. That's not really going to help us. Look at the number 25. What can you tell me about that number 25? Yeah. Anything else you know about the number 25? It's true. Oh, so 25 is a what? Is a perfect square. Is x squared a perfect square? Is that a difference of 2 squares? Everybody remember this? A plus B times A minus B. Right? Okay, so let's factor this thing. Factor it. It's going to work just like this up here. No. X plus. No. No. 5 times x minus 5 equals 0. Right? A plus B times A minus B. Don't forget difference of 2 squares, guys. All right, you know what to do with this now, right? What do we do now? What does x equal? Or equals 5. You know the shortcut to write this? X equals, anybody remember? Plus or minus 5. I've shown you that notation before, right?
Yeah.
Yeah, I have.
I think it was like 1 time.
Okay, well now this is 2 times. It's not very hard to remember, just right? You don't have to, it's just more convenient, right? Plus or minus 5. Let me show you another way to solve this, because it does not have an x term, so it doesn't have to equal 0 to solve it. So let's do this. X squared minus 25 equals 0. So normally what would we do then? We're not going to factor it. Add 25 to both sides. What's that leave us then? X squared equals 25. Well, I don't want x squared. How do I undo squaring x squared? Take the square root. But I have to do what to the other side? Right? What's the square root of x squared? X equals, hold on. How many answers do we get when we take a square root? 2. So x equals what? Or? Okay, so x equals plus or minus 5. 2 answers. Right? You understand when I write it that way. It's 2 answers, right? 2 solutions. Okay? Right? The only reason we could do this one this way is because it doesn't have what in it? An x to the first term. Okay? All right. On to D. See, remembers how to do this one. Does it need to stay equal to 0? Because of that 5x, right? So we're going to need to do what to it? Factor it. Oh no, there's a 2 in front of the x squared.
So you divide all of that. No, you multiply 12. No, you.
Well, okay. A lot of you guys are saying it's the right thing. What's the first thing you always look for? If there's a GCF, like if GCF was 2, that'd make things real nice, wouldn't it? Can we factor out a 2 from everything? Oh. No, I can't. Doesn't help us. So do we have to use that little A times C method?
Oh, I remember that.
Let's see if we remember that.
That's my set.
Yeah, go ahead, Keegan. So I check what? 2 times what? No,
That's 12, sorry.
no. 2 times
Negative 12.
-12 is,
Negative 24.
okay. So I need 2 numbers that, what?
Add to 9. Multiply to negative 24.
Yep.
And add to 5.
Multiply to negative 24 and also add to 5.
I think it's 6 times. Negative 6 times 4. No.
6 and 4 only has a difference of 2.
Oh, wait.
So maybe some other numbers that multiply to 24.
8 and negative 3.
8 and negative 3. Let's see. Let's check it. 8 times negative 3. Does that give us negative 24? Okay. And again, this stuff with the AC method, you don't always have to do this. I'm writing it out so you can, right, when you get better at it, you won't have to do this. And now what's 8 minus 3? That's the 5 we need, right? Okay.
So it's split into 2 middle.
Now we split up that middle term, right? So it's 2x squared, what?
Plus 8x.
Plus 8x
3x.
minus 3x minus 12 equals 0. You keep that equals 0 there, right? Is this coming back to you? Now what do we do? Factor by grouping, right? First group, GCF. Come on. 2x. Leaving us plus 4. Oh, so you went negative 3x plus 8x? 20. Oh, man. No. Okay, GCF in the next group. Let's factor out a negative 3, leaving plus 4 equals 0 still. Okay? Now what's the common factor? Whoa, we haven't done, we're not done factoring. X plus 4 comes out, leaving equals 0 still. Don't drop the equals 0, right? Bad, horrible math. It's awful grammar. All right, now you know what to do, right? What do I do with these two factors? X plus 4 equals 0, or X minus 3 equals 0. Okay, that's a 3. I'll make a better 3, I guess. Gonna have some standards around here, huh? All right, what does X equal over here? What do we do over here? No, Don't divide by 2.
X equals
How about 2x equals 3 when we add 3 to both sides? And now x equals what? 3 over 2, 3 halves. Or. Okay? Get the hang of this now? So the only thing new is setting the factors equal to 0, right? Now we're just like reviewing how to factor some of the stuff we've done before. Okay? All right. Let's look at this last one here. Let's read this over. Find the zeros, aka the what? Solutions, also known as the x-intercepts, right? Okay? Of y equals 3x squared minus 6x minus 24. How? Algebraic, like we've just been doing. So that means that we take this equation and replace the y with a what?
0.
0, but I'll put it over on the right side. So what am I going to write? Okay. Does it need to equal 0 to solve it in this case?
Yes.
How come?
Because you have A, B, and C. Because you have
Okay, yeah, I guess ax for bx, right? Understand, right? Sure.
Wait, no, the greatest common factor is 3.
Okay. Yep, that's true. Because maybe some of you were thinking, oh, we got to use the AC method here, right? But again, always look for what, Tegan? If we could factor out a 3, couldn't we? Wouldn't that make life easier? Okay. So let's factor out a 3. Does that leave us?
X squared minus 2x
Equals 0. Okay. Oh, it'd be nice to be able to just ditch that 3 altogether, wouldn't it? Divide what by 3 exactly? Both sides. Can I do that? All right, what's that leave us then? Equals 0 divided, see? Like we still divide 0 by 3, it's still 0, so we
You can divide 0.
can't divide by 0, you can't have 0 on the bottom. You can divide 0 by things. Okay. I'll let you guys take it from here. Let's see who gets it. Just get halfway done. X and X. What do the numbers have to multiply to? At the same time, add to? Okay, go ahead, do it. Okay, so we had -4, +2, right? Serenity, what'd you get for your final answer?
X equals 4 or X equals 10.
Right, so X -4 equals 0, or X plus 2 equals 0, X equals 4, or X equals -2. Circle your answer. That's an equal sign. There we go. All right. Some of us are getting here. So that's algebraically, right? So if we were to graph this, we would assume that the graph is going to hit the x-axis in what 2 places? We got here and about here, right? So what we need to do then is they want us to put it in the calculator, make this your window, right? Remember how to go to window settings? X from -5 to 5, Y -30 to 30. And there is a function in analyze graph that should allow you to find the zeros. Oops. Oh, I didn't change my window. Menu, I guess it's not super important with this one, but let's see. 1, 5.
-5, 5.
It's what's on the graph in your page.
Oh, I mean that equals x 3x plus
Oh,
x
that,
squared minus.
the equation, right. Should look like what I have there. Yeah? So you have that. Let's go into analyze graph. That doesn't, something not right there. Oh, this must not be counting by two. I see. They got weird. I was looking at, it's counting by 0.2s. Whatever. We could change that though. I don't like that. Let's change that. I wonder why it did that. Oh, because it's defaulting. Let's go to window, window zoom. I don't like that. Window settings. Yeah, you see the X scales on auto? Let's go down and just have it go by ones. I think we can just type in a one. Wait a minute. Just type in one. There we go. Enter.
Oh yeah, that's it.
Now it looked right. Now we can see our 4, -2. But also, let's say it was like that, right? And maybe it doesn't hit exactly on a number. Let's go to menu, analyze graph. Does anybody see something that'll help us here? No. That's like with another graph. Guys, what's the title of this section?
Oh, didn't that?
No, what's the title of this section? Oh, 0. Let's find a 0. They only find one at a time, right? And remember, this is where you use like the slider. So let's get below one of them, hit enter, get past it. So -2, 0, right?
Yep.
We can find the other one, menu, analyze graph, 0. Yeah, that's below it. Let's go to the upper bound, past it. -2 and 4, so graphically we got it, right? So let's go through the sketch in our book then. And notice how far down it goes. It goes, down to, geez, what, like -29-ish or so there? No, -24. I'm looking at the equation. That was silly. No, not -24. It's what it hits. It's -24 here, and then it's something else there. But anyway. All right. Right. Yes. All right. So here, like -24, it's going to hit the axis, right? Doing y-intercept. And we got, there's -2. And then 1, 2, 3, here's 4, right? And just roughly it there like that. That's supposed to be a 4. Okay? And notice our intercept here, or our 0 there and 0 there. Yeah. Okay. All right, so we learned how to factor quadratics before, right? So like when you do your problem set, maybe you'll look back in your notes at some of that, right? But the new thing today is if a quadratic has an x squared and an x term, what does that have to equal to solve it? 0. And then you factor it. What do you do with the two factors? Set them each equal to 0, solve them on their own. You got your zeros, aka solutions, right? All right, let's do. There's only a couple of Regents questions. It won't take long. All right. Read the first one. What do they want us to find? Otherwise known as intercepts, otherwise known as solutions, right? So what do we do with this function to find the zeros? Set it, well, first, yeah, at some point. But first set it equal to 0. And does this need equal 0 to solve it? Yes. And it doesn't always help, but the first thing to always look for is what? Right? So go ahead and try this one, kids. If there's no GCF, you just got to use one of your factoring methods. Okay? get it factored, right? There's no GCF, right? So we get halfway done like we've been doing for a while. X and X. The numbers here have to multiply to what? Negative 24, and also add to, what are those numbers? What is it? Negative 6 and what? Positive 4. It doesn't matter which side you put them on, right? So now what do we do? That's parentheses. What do we do now? Set them each equal to 0, each factor equal to 0. Separated with the word or. And you get x equals 6 or x equals negative 4. Choice 3. All right. I'm kind of okay with these, baby? Probably it's just remembering how to factor certain things. You might have to flip back in your notes on, right? All right, let's look at this one. Ooh, it's a little bit different. Move that over. It's a little different now. Yeah. Hey, is this a quadratic function?
Yeah.
Does quadratics have x squared as their highest exponent, right? Wait a minute.
And then there's X.
Wouldn't it, if we distributed through, wouldn't there be an x times x times x at some point? So it's cubic, isn't it? It's x to the third. Oh, that's completely different then, isn't it?
That's the, right?
Yeah, that's the different graph, huh?
K is, isn't this just like X equals negative 3?
Is it really completely different then? No. Hey, Mr. Miller.
I just not coming to tell a story. I want to see. I didn't want him to think who it was.
You don't want, oh, I see. So you're playing coy. Yeah, okay.
Oh,
Yeah,
this
that
is
helps.
nice. That was nice.
Yeah, that makes
Oh,
you,
that's better.
that makes these people look a lot better. Thank you. Yeah, by the way, the whole, listen, the zero product property, that if A times B equals 0, then A equals 0, B, if A times B times C times D equals 0, right? Then either A equals 0 or B equals 0, C equals 0, right? Any number of things multiplied. So it's not just the two that we had, right? So what would we do? We would set the whole function equal to 0, and then what? This is like two parts. Like I think on the actual Regents exam, they'd be separated. So wouldn't we set the function itself equal to 0? The whole thing? Set the function. I don't know why they have you explain it and then do it. Like, wouldn't doing it be sufficient to know you could explain it? But whatever. You can play a little game. Set the function equal to 0. Then do what? Then set, these are factors, right? Each factor equal to 0, right? Okay, so I guess we'll do that, right? So step 1, set the whole function equal to 0, yeah? X plus 3 times x minus 1 times x minus 8 equals 0. So Randy, what's our next step? Well, did I do that up here? I did. There's an in-between step you need, which is what? What did I do with these two things? So that's what I'm looking at, right? You were getting a step ahead. Plus 3 equals 0. Go ahead. Wait. You missed something. Or.
X minus 1 equals 0. Or
Here we go.
X minus 8.
There it is, right? Now, I know in your head you were going straight to the thing here, right? To the solutions to it, just by switching the signs, right? And by the way, just as a connection, you notice how these are in parentheses? And the things we're looking for just has the opposite signs? Does that sound familiar? Oh, okay, just checking. So what does x equal here? Or x equals, or, and then circle them all. Simple as that. Okay? So I think maybe the only thing you might have to flip back and where you know it's in is certain ways to factor certain other things, okay? Okay? All right, well, there we go.